This was a very interesting presentation to create, but as I was doing it, I was thinking to myself, right, we are in the year 2015, we've achieved a lot as a community, as an industry. My man Eric out there got his VCDX. Go Eric. V-balls have come out, V-balls, apparently they're big in Canada. Go Canada. We are doing software-defined data centers, right? We are done with virtualization, everything works, and now we are building, data centers that are containing, tens of thousands of virtual machines, and we expect them to run all by themselves. So that's where we are. It's the year 2015. But, the year 2015 is also filled with a lot of ironies, right? We can locate an iPhone, but we can't locate an object 2,000 times its size. Is that right, Ladan? You lost your bag, right? So, that's a problem with the year 2015. Final Fantasy is still not final. I think they should start calling it the semi-final fantasy, or I don't know, the Sweet 16 fantasy or something like that. It is also ironic that we are working on this concept of the software-defined data center, but we do a lot about deploying VMs and maybe monitoring them, but we do almost absolutely nothing about actually understanding what runs inside our data center. And so we are caught in this constant cycle of actually fighting fires. That is pretty ironic in the year 2015. So one agenda item on my mind is that we are going to show you a way to fix that. And PernixData as a company is going to do a product to solve that. It's also equally ironic in the year 2015 that enterprise IT is the most siloed industry ever. Right? You can't answer a very simple question, is what is a person like me who works for a company like mine running in their data center? A very simple question, and you don't know the answer. And so you go to VMugs, maybe you think, you talk to other people for 2 minutes, and maybe you think you know a little bit, but in reality, the data-driven way to get all those answers, how the world is, how the planet's data centers are actually evolving, that is missing. And we are going to solve that. And it's also equally ironic that it's the year 2015, and a disk array that actually costs $20,000 in components is sold to you for $100,000, under the guise of performance. And then you use it, and it's one thing if it actually works, but it's a totally different thing if it actually, you spend $100,000 and it doesn't work. It's ironic to be in the year 2015 and suffer from that kind of quality of service from engineering. So we are going to fix that today. And last thing, which is not ironic at all, I think, is, it's been 2 years doing FVP, and, as a platform, we are incredibly proud of what it does today, but I'm going to share with you a few things that it's going to do tomorrow. It's going to be a technology preview. So, first things first is, the great thing about doing a product like FVP is you learn a lot, right? You talk to customers, and just like Jeff was saying, we've had the great privilege to sell to all kinds of, users, right? Going from the Fortune 50s of the world to the, SMB type environments. And, different people have different priorities. And, we actually heard a lot of feedback from FVP. And ironically, a lot of the feedback was not on the data path, the core acceleration piece, right? The thing that we do, right through VMs, right back VMs, right back with fault tolerance. All that was pretty obvious to people. But a lot of the feedback was about using the FVP UI to actually understand applications in a way that they have never been understood before, right? So I'll give you an example. There is a customer in the UK. They deployed FVP, and he comes in over a weekend just to, maybe play a video game, whatever. But, he was in over the weekend, and he saw that one of his VMs, his database VM, was doing a lot of IOPS. Now, FVP was accelerating it. So if you actually look at the first level of the problem, there's no problem, right? It's doing a lot of IOPS, and FVP is giving him sub-millisecond latencies. So there's nothing more to look at. But the funny thing is, this person actually, realized that it's a weekend, and the VM shouldn't be doing anything in the first place. And so then he started digging, right? And, so he started off with the FVP UI, and that's the UI that shows him that it's doing a lot of IOPS. And yes, it's going fine, but he actually cared to ask the secondary question, is it even reasonable that the VM is doing a lot of IOPS on a Saturday. And it turns out it's not. And eventually they debugged it to the fact that it didn't have enough virtual RAM. And so, it was doing a lot of swapping without really doing a lot of work. They fixed that. Absolutely a problem, absolutely unrelated to FVP. But they actually started with the FVP UI and they learned something new about the data center. And same thing, another environment, they were using a hybrid disk array and they had performance problems. So the first thing they did was add more flash to their hybrid disk array. This one is a platform that only does read acceleration. And after adding all that flash, they didn't get any benefits. And so they came over to PernixData, they POC'd FVP, went well. But the highlight of the POC was for the first time they actually understood that they were actually running a workload through our charts whose IO characteristic wasn't suited in the first place for a read-only acceleration medium. And so if you are going to solve the problem, a performance problem with the wrong solution, obviously you're not going to see the benefits that you're seeing. So lots of these examples, where actually people figure out non-intuitive things about their environments, just looking at a product that is apparently doing something totally different, but the product actually lets them discover these things. Along the same lines, a lot of interesting, frequently asked questions, right? When we do FVP as well, how much flash should I add to my servers and dedicate to FVP, or how much memory should I run with my FVP cluster? And, when we first heard the question, how should I design the disk array? How much more SATA spindles can I buy before it keels over because I'm running FVP on top? And you hear those questions and, the first reaction, at least I had, was, well, don't you already know? Don't you actually use tools or pay some consultants a lot of money to actually figure that out? So what's missing here? Why are you asking me these questions? And it turns out that people don't quite know. And even if people know, which is true, when you start off deploying your first 2 machines in your data center, it turns out, your data center progresses at such a speed. You provision VMs at such a speed. You provision new solutions, backup, DR, etc., which actually adds more and more and more overhead into your data center at such a speed nowadays that your finest designs are bound to be out of date as soon as you stop, finish printing them. That is the problem, right? So it's not a problem about not knowing. Even if you try, you are not going to know about it. And then we also, as we dug deeper, we figured there are basic tools are missing, which actually take you from this monitoring realm, where you are actually busy in your data center just looking at red and green lights, and actually trying to chase the problem du jour, to this, understanding realm, where you can actually spend time in your data center understanding what workload you are actually running, so that you can, deploy that workload in the right way, and you never get to the red light scenario in the first place. How about that? And so we figured, if we can solve these problems, if we can actually take people from a operational mindset to a learning mindset, and if we can actually provide a tool to make that happen, that'd be awesome. And of course, it would make us some money, but you didn't hear that. So here's how we look at the IT problem. The next thing we saw is, well, what are the interesting tools in this space that exist, and why aren't they solving the problem, and how can we do better? And so this is roughly how I see the IT lifecycle, right? You first design your data center and then you deploy it. And by virtue of buying a particular storage system, some servers, some network switches, etc., by virtue of deploying some applications that you like, and then you operate the data center. You look at the red, green lights, and eventually you learn from it. Well, it doesn't happen, but theoretically that's what should happen. And you figure out what you should do better, and you roll that into your next design, and then deploy the next design, and on it goes, right? That's the IT lifecycle. And it turns out that, well, partly it's the vendor's fault, as we, the vendors, deliver a lot of solutions in this part of the IT lifecycle. You get storage systems, you get things like FVP from PernixData, a lot of, so you get network switches, etc., which will help you with your deployment. But not enough people actually help you with this part of the lifecycle. This is mostly Excel spreadsheet, a lot of consulting hours, where the consultants might actually give you some information, but it might not necessarily be very relevant for your data center. Even if it is, it might go out of date, like I was saying, in a few days, months, weeks. So not enough happening here. And partly not enough happens here because it's a very hardcore technology problem. I'll actually enumerate exactly what that technology problem is later. some stuff is happening, right? So you get some operations management products, maybe you get some planner products. But tell me how many of you guys have used a planner product, and the first thing the planner product does is it needs you to fill out 20 numbers, and you make each number up, right? And then once you make those numbers up, you say calculate, it's going to output an answer for you. You don't like the answer, so what do? You actually make some new numbers up until the time that you actually get the answer that you want out of the planner product.
Garbage in, garbage out.
Garbage in and garbage out, exactly. Actually, that's what my co-founder says, Pujan. So you feed it crap data, you're going to get crap results. That's the problem here. The problem here is the mindset, right? If you're going to make people run like hamsters in a wheel, if they are always going to chase the next red light that happens, you're never actually going to get to the point where you design your data center in a way that the red light doesn't happen in the first place. So that is a good thing, right? You need to know something, everything that's happening in your data center. Don't get me wrong, that's a good thing. But, unfortunately, people overspend time on this part. So we digged a little deeper, went into operations management. We figured, can we do, why is ops management not quite sticking? If people are using ops management product, and it turns out this is a customer survey that we did. This was more than 100 customers. So this is not the Gartner's class survey where they call 10 people, but it's a reasonable set. And what we found out was, some of them were, a third were actually using some kind of ops management product. A quarter were actually satisfied with what they use, and then the rest weren't. Some guys said that we would love to use it, but we don't think we are there. And that's a very funny answer, right? How can you be in the year 2015 and think that you are not there? The reason you think you're not there is because you think that the only guys who deserve to run this great enterprise lifecycle is the Fortune 500 companies in the world, and that is absolutely not true. That is the same problem we had when we first did PernixData, right? If you ask some small company, do you deserve 200,000 IOPS in your storage system? And they're like, no, we are not there. No, you are there. It's just that you can't afford it, so you're giving me the wrong answer. So same thing here. They think they don't deserve it. And these guys, of course, are not looking at it because it's not a priority. Well, why is it not a priority? Because if you don't find something beautiful to actually chase, why would you chase it? And so out of the 25% people who actually said that we use it, we asked the second question as well, why do you use it? And these are the, very sad answers. Like, yeah, well, beats running blind. Great, I buy that. The other one says, well, it came free with my enterprise license. Well, is that even an answer, And so, unfortunately, it's missing the wow, the thing that you actually go home and, talk to your wife about, actually, well, whatever, talk to your Twitter friend about, right? So it's missing the wow. And a technology without wow is not going to go too far, in my opinion. There are a few tools which are unfortunately limited because of the scope, right? So some tools in the array, but unfortunately they only show you things about the storage system, nothing else. That's not interesting because your data center is much more than the storage system. A few tools on the server side, some of them mine other people's stats, and which is pretty good, but longer term, unfortunately, you have to have your own data. Later in the presentation, I'll tell you why, and so on and so forth. Some tools that have just been a evolution from legacy, right? Those tools were actually managing physical machines, and one fine day they figure out that it makes sense for their product roadmap to manage virtual machines, and so they manage virtual machines the same way they manage physical machines. That's not interesting. So that's one thing, that's one thing that is wrong, which is, unfortunately, we are in a place where we are faced with a very critical problem, which is, do you even understand your data center? But, the tools that are kind of, available to solve that problem are unfortunately early. And again, don't get me wrong, it is the, typical engineering life cycle, right? You make a product, you learn from it, and then you make a better product. And so it just so turns out that because we made FVP, and FVP had a lot of monitoring capabilities, we actually had the privilege of learning about what actually people want. or people like, or what doesn't work. Here's another thing, the third thing and the final thing that I'll tell you doesn't work, right? Focusing on the wrong thing, making people hamsters where, they look, the whole point is to sit in the data center or the ops room and look at red blinking lights or green blinking lights and try to turn them green every time it becomes red. That's interesting, but at the end of it, you're not adding value to your job. Here's what's contemporary, dashboards. And again, don't get me wrong, this needs to be done. But the problem, as soon as you do it, is what happens when something turns red? Well, you're supposed to turn it green. That's the first rule in the playbook. But how do you turn it green? Well, that is a part that this tool doesn't actually provide. It actually tells you that a statistical anomaly was detected. And that's a good first thing to know. But after then what? If you are not going to tell me how to solve it, how am I going to wade through thousands of data points in my data center to actually fix it? Here's another problem. Look at this. This is some Oracle database thing. Redo buffers, 19 megabytes. How does one know that 19 megabytes worth of redo buffers is a good thing? What is a bad thing? Is it 17 megabytes? So the problem is, we are showing the wrong things. I mean, why are we actually burdening users with concepts that a guy implementing the database should know about, but nobody outside the database vendor should know about? But that is what we have actually devolved to. And we actually think this is good, right? Because, you go home and you're like, oh, well, now I know how Oracle works. But, is it scalable? Is it, now Hadoop will come up and now what? So it's not a scalable way to actually understand your data center. Here's a UI designed by a kernel engineer. How cool is that, right? And you ask the vendor that you need something better, they'll probably turn the blue bars into teal. That's the next version. But that's the problem is, what we computer scientists think is useful inside the kernel actually shows up on the UI. Is it useful to run your data center? Probably not. But this is the state of the art. And so bottom line, we think that not enough work goes into this part of the IT lifecycle, which is very, very important because this is how we are going to grow. This is how we are actually going to do a private cloud that is potentially better than a public cloud. Otherwise, it's time to give up. And even if we go to the public cloud, we actually need to understand what we are running in the public cloud, our own applications. So it is very important to at least solve that problem, even if we don't solve the red light, green light problem. So this is where we come in. We figured this is an interesting problem to solve. We are on the server side. We have the operating systems DNA. And so we got to do much more than just build storage systems. And of course, we are going to do all that stuff as well. And as you hopefully can see, FVP does a great job so far. But when we actually started looking at why people have not done it, it was obvious. It is actually a very hard problem. First you got to collect the right data, and it turns out to collect the right data, you actually need to be the data source. You can't rely on somebody else's data source, and so that's a hard problem. People typically rely on somebody else's data source. And that's the butterfly effect. Somebody just said it, right? Is, if you garbage in, garbage out effect is, if you start with the wrong data, your conclusions are going to be wrong. It's a big data problem, right? To actually understand everything comprehensively, not by humans, by the way, by machines. You need to actually collect a lot of data, but then, it turns out the more you collect, the more you have to store and crunch. And so it's a big data problem. It's very, very hard. I'm sure you've followed VMware as it has tried to scale, vCenter from 1,000 virtual machines to 10,000 to 50,000 and so on. And it's not trivial at all. And it's an analytics problem, right? You've got to actually collect this data and act on it before the actions that you are going to recommend actually go out of date. And so it's actually, you got to be very fast about that as well. And that's not very trivial either. You pretty much have to run a separate data center just to run the analytics, right? That's the irony of it. And then, of course, it requires some kind of AI, right? This ontology is, technical term. For example, that's how Siri operates, right? You can actually ask it a meta question, like, do I need a raincoat today? And it's going to actually show you the weather. And the reason it does it is it associates the concept of a raincoat with the concept of rain. associates the concept of rain with the concept of weather. And so it knows that for this question, you actually are looking for this answer. And so it's about actually answering questions at a meta level, not providing obvious answers, but actually the right answer that the user was looking for. And that requires you to know how everything in the data center is actually connected to each other. What is the cause-effect relationship? For example, if you unplug a network cable, then you need to know that, well, it might disrupt virtual machine traffic, it might disrupt iSCSI traffic, it might disrupt vMotion traffic, it might disrupt NFS traffic. And so then you do a level further is, you go to NFS and then, figure out, if you have some data stores. And so now if you ask the question, what happens if I unplug this cable? And the answer is that this data store is going to go offline, right? And which is a very different answer from actually showing the network cable as red and then having you figure out what's going to happen later.